This is Module 4, Lesson 21, titled Writing and Evaluating Expressions with Multiplication and Addition. Our goal for this lesson, I can write and evaluate algebraic expressions involving multiplication and addition from real-world problems and patterns from a table. As always, take good notes throughout. Pause the video whenever you need to, or watch the video as many times as you need to. Now, from our goal, we can see that we're going to be looking at tables and trying to figure out the patterns in order to come up with expressions. But the difference this time between previous lessons is this one is going to have not just one operation involved, it's going to have two. We're going to be dealing with multiplication and addition. To illustrate how this is going to work, let's go to the mathematical modeling exercise. I'll read the problem to you, read along with me. It says, the Italian Villa restaurant has square tables that servers can push together to accommodate the customers. Only one chair fits along the side of the square table. Make a model of each situation to determine how many seats will fit around various rectangular tables. So we have the little models in front of us. If I look at this first model here, I'm going to move it around so you can see which one I'm talking about. It's a square table. It's one square table. And if I wanted to know how many people sit around that, I'm going to make little marks so that you can see a person. I have one on each side. That means I could have, for one square table, 4 people sitting at that. I'm going to move that off to the side. Let's assume that for more customers, they decide to move 2 square tables together. You have a party that's larger than 4. So if they move 2 square tables together, how many can sit at the table? Okay, so we can put 1 on each end there, side there, and then of course they can sit at the end. So in that case, there's going to be 6 people that can sit at that table. Okay, if I go to the next one, let's say we have a larger party. We can have 3 tables together. How many people could sit if 3 tables are together? You have 1 person on each side, and then 1 on each end. That means we can have 8 people sitting at 3 tables. At 4 tables, we can have 1 person on each side, and then 1 on each end here. That tells us we have 10. And then if we have 5 tables pushed together, we can have 1 person on each side of the table, and then 1 person at the end. Tells us we're going to have 12 people sitting at that table. Now, before we fill in the rest of the table, we've got some questions to think about here. First of all, it says, are there any other ways to think about solutions to this problem? To figure out the pattern of what we're doing, we got to always remember what's going on here. In every one of these, we had 2 people that could sit on the sides of the table, and then 1 person at each end of the long group of tables. Okay? So we can say, regardless of how many tables there is 1 chair on each end, and each table has 2 chairs opposite the other. It tells us we have 2 people at each side, and then 1 on each end of the long group. Now, it's impractical to make a model of pushing 50 tables together to make a long rectangle. If we did have a rectangle that long, how many chairs would fit along the sides of the table. Based upon what we just said, we said that for every table there's 2 people on opposite sides, and then there's 1 on each end. So if we think about it this way, 2 people on opposite sides of 50 tables equals 100 people on the sides, and then you have 1 on each end, so you add 2. That tells us we would have 102 people on that long table. Okay, so that's the next answer. 102 chairs would be on, oops, I'm jumped the gun there. Let me back up here. 100 on the sides, and then you have 2 on the ends, and then how many chairs in all? You would have 102 chairs. So for 50 tables, back on our table, we're going to have 102 chairs in. Now, it says, work with your group to determine how many chairs would fit around a very long rectangular table if 200 square tables were pushed together. So we could say 200 tables times 2 chairs on each side plus the 2 on the end. We can calculate that by using correct order of operations. We would have 400 plus 2, and that would mean for 200 tables we'd have 402 chairs. Now finally, it says if we let T represent the number of tables that make one long rectangular table, what is the expression for the number of chairs that will fit around it? Remember what we did as far as a pattern. We multiplied 2 times the number of tables to represent the number of people on the sides, and then we had 1 on each end, so 2 ends we could say is 2. Our algebraic expression for T tables would be 2T plus 2 chairs.